Okay, so let's start with a new topic now. We'll look at the nested types, right? What are the nested types? Okay. Fine. Mainly the nested classes. So let's start and let's look at this. What kind of members go in a class definition? So if you define a class, right? So you'll say, okay, you have a class. You'll have some modifiers for the class. You have a class name. You have extents. You have implements. Okay, but inside the body of the class definition, what are the members which will go? Fine. You have instance variables. You'll have the class variables. Fine, we can have the constructors. Okay, you can have methods. You can have static methods or the class methods. Methods, okay, let's say static methods. Fine. We have the blocks, the static block. Fine. We have the initializer block. Yeah. What else can go in a class definition? Fine. Oh, this is the list we have, right? So far we know, this is what can go in a class definition, right? Fine. So inside the body, okay, you declare a variable, it becomes an instance variable. Declare static, it's a class variable. Fine, you can have a constructor having the same name as the class name, have parameters. Fine, so you can write a constructor. Fine. Then you can have methods with a return type, and you can put a static block. We have seen the purpose of each of those. Okay, fine. So over and above all that we have seen so far, what are members of a class? Okay. Inside a class definition, we can also have another class definition. So there can be a class inside a class. Fine. You can have a nested class. You can have an interface inside a class. Sorry. You can define an enum inside a class. You can have an annotation also. So all four types, fine, which can go in a Java file, fine, they are basically members of a package. See what we put in a Java file, they belong to a package. Okay, but then these four things, the class, the interface, the enum and annotation, in turn can also have another as a member. So it's a member of the class, right? Here it's a member of the class. Otherwise, this class is member of a package. The class which is here is member of a package, but this class is a member of a class. Okay, fine. So one is a class which is directly member of a package. Other is a class which is member of another class. Okay, fine. Just like you can have these four things inside a class definition, same way it's possible to have all of these four as member of a interface. So if I am defining an interface, let's see what are the things which go in an interface. Okay, so if it's an interface, you have the interface name and extends and other things are there, but the body of the interface, yeah, what can be there in the body of an interface? We can't have instance variables, right? We have static constants, fine. There can be static constants. There are no constructors. Since there are no instance variables, there are no constructors. And because the role of constructor was to initialize the instance variables, there are no instance variables in this. Okay, fine. We have three kinds of methods. No constructors, but three kinds of methods. Yes, we can have abstract methods. Okay, that was the first thing it started with. Yeah, abstract methods. We can have, you have the default methods and you can also have the static methods. An instance for an interface. These are the members which go in a interface. Plus, what else? This can also have a class definition. An interface, or enum, or annotation. Fine. The idea is all the four things, each and every of them, even inside an enum, you can have all the four items as a member. Inside an annotation, all the other four are members. And that's why I use the term nested types. Okay, mainly it would be about the classes, but interface inside an interface also common. Okay, fine. You can have others as members inside the. Fine. So these are the nested types. When they become member of another type. Fine. One is member of a package, other is member of a type. Nested type. Okay. Fine. Now a few things about a nested type for each of those four, right? Now if I just consider, so let's consider a class inside a class first. Okay, so as member of a class, so you have a class name. As member of a class, what are the access specifiers for members of a class? Fine, there are four access specifiers for member of a class. What are the access specifiers for members of a package? Only two, public and default. A class which is member of another class. A interface which is member of a class. Enum which is member of a class, or annotation which is member of a class. What are the access specifiers for them? All four. There, any member of a class will have all the four access specifiers. Okay, fine. So one difference between the class which is member of a package and class which is member of another class. Right? Members of a class have all four access specifiers. Okay, now inside a class, when I am having another class, so one is all four access specifiers. Other is, okay, for a variable. Suppose let's consider the case of a variable. If I declare a variable inside a class, There are two types. Variables are two kinds, right? Instance variable and class variable. The difference is the declaration of static. Fine, we declare variable to be static or non-static. Same way, a class inside a class can be static or non-static. This is optional part. Okay, so you have two kinds of classes when they are member of a class. You have two kinds of classes when they are members of a class. They are either static or they may be non-static. Okay, there are two different terms used for them. A static member class, a static class is known as top level nested class. So if it is static, fine. So if it is static, right? Static and non-static, a simple class. So if it is static, this is known as, we call it as a top level nested class. And if it is non-static, then it is known as a inner class. Fine. A class inside a class can be static or non-static. Okay. A static class is known as top level nested class, whereas the non-static member class is known as inner class. Okay, see, what's the difference between static and non-static? For a variable, for a method or anything, what's the difference? Non-static means requires object. Without object, we don't use it. It's not usable without the object of the class. Static would mean whether you have an object of the class or not, you can use it. Fine, whether we have the object of a class or not. It does not require the object of the class. If there is a static method, inside a static method, I won't have any object of the class available. A non-static method implicitly has a object of the class available by using the word this. You have that keyword this. Okay, it provides nothing but the object of the enclosing class. In a method, if I am not using a static method, right, a simple method, fine, we have the object of the enclosing class available inside the method by using the word this. So object is available. Fine. Same thing applies here. A static class, okay, a static class would have no dependence on the requirement, it doesn't need any object of the enclosing class to be available. Fine. There is no requirement of enclosing class to be available inside the static class. You don't have that object available. But if there is an inner class, fine, if there is an inner class, when I am saying inner class, it means a non-static one. Okay. Whenever we have an inner class, inside the inner class, there are two implicit objects now. See, inside any class we normally have one implicit object called this. We have one object this, which is the object of the class. Inside our inner class we will have two objects. Which are the two objects? One will be the object of that class itself. Clear? Okay. So within this, if I say this, it's nothing but object of which class? The inner class object. Fine. Oh, but we also would like to be able to use the object of, there have to be two objects, because this is not a static one. This class is not a static class. And therefore, there must be two objects. One is the object of the class itself, which, so this is nothing but the object of that class itself. Now let's say this class is, the class has a name, right? Every class, here it's a named class, right? It's not that anonymous one. Fine. So for this class, suppose we have the name called, okay, some class. Okay, let's say the class name is like this. Fine. In which case, the object of the enclosing class, there will be one object of some class also available here. Okay, so that's going to be available as some class dot this. Okay, two implicit objects. Earlier we had only one implicit object. Fine. That implicit object was this, the object of your current class. Okay. But this class is an inner class and has an enclosing object. The object of this class, the inner class, has a object of the enclosing class, and that's going to be available by using that enclosing class name dot this. And whatever is the enclosing class name dot this. So two implicit objects would be available here. Fine. There's one restriction in case of inner class. Fine. We understand what members go in a class definition. So there is a restriction in what goes in an inner class. A inner class cannot have any kind of, so no static members. For an inner class, there are no static members. We cannot have any static members. You know what members go in a class definition? Fine. Instance variables, static variables, methods, static method, constructor. Fine. So all that goes here. It goes in a tuple level nested class. Tuple level nested class has all the same kind of members. But when it's an inner class, static members not allowed. Other things are fine. Rest of the things are there, but no static members. Fine, clear? See, when we define a class, what are we doing? Any class we are defining, you are creating a new data type. Okay, defining any of those 4 items is nothing but creating a new data type, right? Okay, so even if we have something inside another class, right, it's a member of a class. So let's say the stat. So fine. So this class is just about creating a new data type. It's about creating one more type. Fine. Okay. Okay, I'll just put an example kind of a thing. Let's give specific names and try to define a few things here. So we have class A, for example. You've got class A. Okay, extends, other things are fine. Inside this, one of the members is another class B. Okay, we have class B inside the class A. Okay, fine. This may be static or may not be a static one. May or may not be static. When I compile this file which contains such a definition, how many class files will be created? 2. Fine, because there are 2 class definitions. Fine, because there are 2 class definitions, you will have 2 class files being generated. Fine. There are 2 data types. Fine. Someone who wants to use the class which is class A, yeah, he can declare a data type A. So somewhere outside you can have a main method somewhere, and he says A1 equals, and uses the constructor of the class A. Right. For this one, what's the name of the data type? It's going to be A.B. It's a member of A. That class definition is a member of A. We'll have to use it as A.B. So the name of the type is A.B. Fine, name of the type is A.B. Okay. So example, you might say, okay, A.B, let's have AB1 equals, yeah. Now let's have a look at the difference between the top level nested class and the inner class. The type B here could be a top level nested class, or it could be a inner class. Fine, top level nested means declared as static. Declared as okay. So first example of top level nested class. So that's quite simple. Yeah, you should be able to suggest how will I create the object. New A.B, that's a type. Use a constructor which is available inside the class B. And this is obvious, right? Okay, fine. But when it's an inner class, what does the inner class say? If it's non-static, it needs the object. In order to use this, you should have a object. So the example would be different, fine. So this would work if it is a top level nested class. But if it's a inner class, fine. So this is for top level nested class. So if it's an inner class, okay, we'll have to comment this and we'll say, we can still declare a dot b ab1 equals, now dependence on the object. And the idea here is you can't create object of the inner class without having object of the enclosing class. Any object of inner class always first needs an object of the outer class. While creating the object, we will have to say for which object of A are you creating this object. Object of the inner class do not exist without the object of the outer class. Okay. Oh, so let's assume we have this A1 which is our object of the outer class. So we want to create for that one. Okay. So we'll say A1 dot new. So A1 dot new, and then don't say A dot B, use B and use the constructor here like this. So the syntax would be slightly different. Okay, two different syntaxes for creating object of the nested class. One is for top level nested class, other is for the inner class. Fine. See, in case of inner class, dependence on the object of enclosing class is always there. There has to be one object for which you will have to create this object. So the object of B, if it's an inner class, cannot exist without having an object of A. There has to be some object of A, then only you are creating the object of the inner class. Find inner class B here. Okay, fine. So inside the class B, we understand there are those two implicit objects. One is the current object of B, and other is the object with which you created B. Fine. Fine. Inside the class B, I could use this, or I could use A dot this. Fine. So when someone says A dot this, which is that object? The object with which the object of B has been created. An object of inner class is not created without associating it with some object of A. Fine. So inner class is slightly different, right? There is dependence on object. Okay. Fine. Now talking about the nested types, back to the more general part. This was specific about nesting a class. Okay. Fine, we understand nesting in all forms. Class inside a class, class inside interface, class inside a enum, or class inside a annotation. For interface and annotation, there is no question of an object existing. Fine, objects are not created. Okay, objects are always created of a class, or we have objects of a enum. Okay, and therefore we do not have any concept of a inner class over there. inside our interface we don't have an inner class, we always have a static class. Fine. See, in all cases the members are always static. In all cases members are static. Only case is for a class, because a class can also be an inner class. Fine, you can have class which goes as a inner class. Otherwise, it's all the nested types are static types. You don't have to declare static, but they are static. And let's just mention it. So let's see this. We have a class. Okay. Fine. What kind of things? Or we can have a static class. Slow क्यों हो गया? Let me check something wrong. किसमें? Okay, so member wise, right? A class can have static class, it can have a simple, so a non-static class which is the inner class. Fine, it has static interface. ये slow हो गया वापस आज. पता नहीं क्या हुआ है. हाँ, चेक करें रिफ्रेश करके. रिफ्रेश कर ही लेते. I'll try reloading it. लास्ट टाइम भी मंडे को स्लो हुआ था ऐसा ना? नहीं, इट वाज मंडे. लास्ट टाइम जो स्लो हो गया था एक बार तुम अटेंड करे थे, फ्राइडे था वो. Okay, fine. So you can have a static interface. There is no concept of a non-static interface. So when you have an interface inside a class, you may not explicitly mention static, but it is static. Because the object of interface has nothing to do, no requirement with the object of a class. Anyway, you don't have object of an interface. Fine. So same thing, if it's a enum, it's a static. Oops. Slow, yeah, baby. Fine, we have the static enum, static annotation. Fine, so they would always be static. That's the whole idea. Fine. So this is, you can see it's always static, except for in case of a inner class. And where are the inner classes allowed? Inner class cannot be inside an interface definition. So if I have an interface, right? If I am writing an interface, oh, we can't have a inner class here, because then it's no object of an interface being created. Fine. So inside interface, we don't have inner class. Fine. This class is nothing but that's our inner class. Fine. That's our inner class. Okay. Inner class is allowed in two places. Rest of the time you can think that all nested types are static types. All nested types are static declarations. Okay, you don't have to explicitly mention, because in case of a class there is a possibility of a inner class, and therefore here you will have to be specifically mentioning static, otherwise it would be considered as an inner class. Okay, so two cases where we have possibility of inner class. One is class inside a class or class inside a enum. Enum have objects, right? So when you have a class inside a enum, so inside enum also we can have a inner class. Fine. So your inner class object, when it is being created, it would be created with respect to some existing object of the enum. Enum has fixed objects. Okay. So one is the nested types. Fine. So if you look at nested types, they are all static members, except for a class inside a class or a class inside a enum. Class inside a class or class inside a enum, there you can say static or non-static. You will have to be explicitly mentioning static. Okay, fine. Okay, another point was about the files being created, right? Yeah, we mentioned it once, but we didn't mention the, did we mention about it? Yeah. Okay, here, coming back to this one. Yeah, here, fine, this is the file. Okay, so if this is the file being compiled, if this is the unit which is to be compiled, okay, we understand there are going to be two class files created. What are going to be the names of the two class files? One will be a.class. The class file name I am talking about, the name of the file which is created. One will be a.class. What's the other one? The other one would be a $b.class. The class file name, the file names, the class file which is generated, fine, the file name would be like this. a dot class and a dollar b dot class. What is the outer class name? Dollar, the nested class type name. So nested type name, okay, not just the class itself, whatever the nested type. Enum inside what? Inside a class? Enum inside a class? See, because enums are predefined objects, but class doesn't have a predefined object. So enum object can't be created with respect to an object of the class, because enum objects are part of the definition itself, right? So they would always be created before any object of class is created. So there's no way an enum object gets created before with respect to an object of a class. You can't be specifying that. Fine. So enums are also, there's nothing like a inner enum. Non-static format not allowed. They are pre-created objects, and therefore, fine, they will not be created before, they can't be created before the object of the outer type is there. Okay. Fine, so file naming also we know now, right? Okay. Now, let's see. Okay, so fine. So the idea of nested. Okay, so why nested? In why nested, let me say, why do we have a static class or why do we have a inner class? And we'll talk more about class now. Fine, a nested class. So why a static class? See, you could be having, just take this example like this. You could be having a class A fine. So one option is, okay, you have this class A and then you define a class B right. Or the other option is, okay, so this is one option. Other option is you have the class A and in this you have a static class what's the difference going to be? B as a member class. What's the difference? Oh, this can have all. Static class can have all kinds of members. A non-static, the inner class cannot have static. That's the restriction is in the inner class. Okay, the restriction is in the inner class where you can't have a static member. Fine, inner class cannot have static member. Otherwise, they are all members which go in a class will go in a top level nested class. Fine. See, it's just like any other class definition. The two are almost similar kind of things. What are the differences? Let's look at the differences in the way this top level nested class is used. Only one difference is, of course, the name. Here I call this as B. Here I'll have to call it as A dot B wherever I'm using. Right? Other difference, this can be either public or it can be default. Here I have all four kinds of access specifiers available. It can be a private nested class. It can be protected also. Fine, I have all four access specifiers. Okay. The other difference here is we understand the keyword private. If there is a private member in A, inside class B, even if I after creating an object of A, can I use the private member on A? I can't access the private member of A. What about the nested class? I can use. Fine. See, they are very closely associated with one another, and the class which you are trying to define would like to be would like to have full access to the members of A. Okay. So we say this is member of A itself, and therefore it's part of A. There's nothing to be hidden. Fine. Same way, anything which is inside B is available in the class A, even if it is private. A private member of B is also available inside the class A. Anywhere, it's part of class A. Fine. The whole thing is, this is the whole thing. Fine. So anything which is private to this entire, is private with respect to the member of package, the class A which is member of the package. Fine. See, access specifiers as far as interfaces are concerned. What are the access specifiers in an interface? Members of interface. What are the access specifiers?
Public, private.
Fine. Public for all and private from Java 9 only for method. Anyway, members are methods only, plus the types. So for the types, no, it's always public. Okay. For the types, nested types, they are always going to be public. And even if you don't declare, it's still public. Okay. Fine. So private is only allowed for method. Fine. From Java 9. Okay. If you are working for Java 8, no, you don't have a private method in interface. Okay. Fine. So just like we had, variables being static and non-static, a member class is also static or non-static. A variable could be declared to be private, protected, public or default. Same way, a nested class, fine, our static class here could be declared as private, default, protected or public. Fine. Okay. Okay. Just to show, we have already discussed this, but I'll just put it again. Okay. Fine. with the help of class A. Fine, I'll just put that again. We have network problems है थोड़ा. कुछ पीछे बैकग्राउंड में कर रहा है. पता नहीं चल रहा है मेरे को. स्टॉप एट बोल क्या. देखते किसको बंद करता है. पीछे क्रोम भी चल रहा है. वो ले रहा होगा. Okay, so let's take an example like this. Yeah, okay, so we may have a class. बढ़िया लग रहा है. When we have a class A, okay, and let's say we have some variable int x here. So x is an instance variable of A, okay, and then we have a nested class B here, which is an inner class. Fine, B is an inner class here. Okay, fine, I'm not taking it as a top level nested class, it's a inner class. Inside the inner class B, again there is another int x which is declared. So B is a separate class definition. It may again have a same variable name as one of the variables, which is an instance variable of A. So there's an instance variable in B. Okay, and then we have this method returns void. We have the method m1, okay, and inside m1 again it has some local variable int x. Okay, same name for the instance variable of A, the instance variable of the inner class, and there is also a local variable by that name. Right. So inside this class m1, inside the method m1, how will I be using all the three? If I have to use the local variable, how will I use it? I'll simply call it as x. If I just say x, that's a local variable, and that should be available. I want the instance variable of B. This method is inside the class B. Fine. So this one is available Fine. So what I am talking is how it's used inside this method. Okay. So this one can be used with this dot x. Fine. We are talking about how this variable is going to be available inside the method m1. Method m1 has a local variable x. Fine. And therefore this is what the actual name is, right? It's this dot x. The x is for the class B, it's available as this dot x. Right? For the class A, x here is available as this dot x throughout except for inside the class B. Inside the class B, how is this one available? A dot this dot x. That's how it's available inside the class B. And so all three are different, okay? Fine, you can see how all three are different. Okay, how will it be used? If someone has to call the method m1, how will it be used? Somewhere someone declares a1 equals new, creates object of a, and then we'll have a dot b, ab1 equals a1 dot new, b uses the construct of b, and then ab1 dot m1, right? ab1 is of type a dot b. The method m1 is a public method. Let me make this as public here. It's a public method of class b. The class here also maybe it's public. These are all public. Fine, I have not mentioned, but just assume they are all public. So I have a public class A. The variable, instance variable x in both cases may be just private, okay? And they might be private. Fine. So ab1 dot m1, fine, that's how it's going to be called. Okay, if you look at the three different x, fine, when object of a1 that a1 is created, yes, it's created here. Let's say this is the object of the class A which is created. Fine, A has an instance variable for x, so that's the x here, which is a dot this dot x. Fine, which I mentioned as a dot this dot x. So this is your a1. Fine, there's a a1 is a reference which refers to the object of a. Fine, a1 is a reference referring to the object of a. That's your step 1. Fine, there is this reference for ab1. If I say ab1 is a reference, fine, how is this object of ab1 created, which it will refer to? This a1 dot new. So with respect to this, I have to create another object. Understand here that this object which is created has its own, this is of type a dot b, and it has its own x. Fine, it would have its own separate x. And other thing which you have to understand here is, for this object there is the object of a which is always available. Okay, so this basically has a reference to this. The reference from the object of b to the object of a is available as a dot this. So when someone is saying a dot this dot x, ab1 dot m1, right? So in ab1 dot m1, when now when a method is invoked, the method is invoked from the runtime stack, right? So in that there is a frame for m1. Let's say main is here and main is calling m1. So x is here. The local variable x is here. Fine. But this method has two implicit reference. This would mean the object which is the object of a dot b, and a dot this inside the method would mean this object. The object of b is always created with some object of a. Fine. You could be creating more than one with the same object of a. Or for this, I might again create another object of b. But one thing, you can't have just an object of b and no object of a for it. That cannot happen because b is a inner class. If b is a inner class, you can't just have it independent. Okay. If this exists, definitely there is some object of a. That's why x is always available. Suppose this is one x and there is one y also, right? Slow हो गया है वापस. There's no other. Okay, so fine, clear? So y will be available even if I don't say a dot this dot y. I might just say y, it would still resolve to a dot this dot y. And if you have y as an instance variable in class A, it's available inside method m1. You may just say y, fine, just like where this was not compulsory. Recollect, we don't have to always say this. If there is a name conflict, you will have to make it distinct, right? Like if there is a local variable by the same name, then your instance variable is not going to be available by just using the variable name. You have to say this dot variable name. Okay, so same way here, fine, y would be available in the method m1. You can just say y, but it actually means a dot this dot y. Fine, they are all three different places, right? There is an object of a being created, so three different x, you can see where they are. And they have their own separate places. Okay, one as an instance of, it's an instance variable for a. This one, first one is an instance variable for a. So only when there is instance object of a, or that x will come into existence. When the object of b is created, this x will come into existence. When the method m1 is invoked, for the duration of m1, that x is available, which is the local variable. Fine, clear about this? Okay. One thing here, inner class. Now I am talking specific of inner class. Top level nested class is just like any other class with a few privileges, private things. Okay. The privilege is about use of private variables, access to private members. Fine, that's the other thing. Otherwise it's just like any other class, static class. Okay, inner class is where the difference is. Fine, it's different. It's like it's object level relationship exists. There is no object level relation in case of static class. Fine. This object always has an implicit object. Object of B always has an implicit object of A. Object of B not without A. So we have kind of a relation between inner class and the outer class, and if you look at it, it can be a one-to-many relationship. One-to-many relationship, fine. Something where dependence on this one can't exist without this. That's what the implication is. Okay. Now, from the point of view of our exercise, what we have done so far, we got our class account. Fine. Subclasses are there: current account, savings account. Fine. Okay. Now, for an account, on an account, what is the interaction we are having? Interactions like deposit and withdrawal. And when we have a withdrawal, even a penalty is also possible. Okay. So the various things which are happening on the account which affect its balance, which would change the balance, the deposit and withdrawal methods, they are the ones. Okay. Fine. We say, okay, that's a transaction happening on the account. On this account, these are the various transactions which are happening, and you would like to have them recorded. On this account, what are all the various transactions which have taken place? Obviously, transactions can't be there without an account. We can't have a transaction without a account object. Every transaction will have an implicit account for which the transaction is there. Fine. So we can have an inner class example here, and we can have a inner class. Transaction can become an inner class for account. Fine. Transaction can be the inner class for account. Okay, so what are the members for transaction? If I have to write a class transaction, yeah, what should a transaction have? Date and time. The date and time of the transaction. Yeah. Then the amount of transaction and the type of transaction, whether it is debit or credit transaction, which type it is, debit or credit. Fine. So whether this transaction has resulted in increase of the balance or decreasing the balance, and that should be known. Fine. And you can have some string to describe the transaction. Some narration can be there for the transaction. Okay. Fine. We don't have to say which account. Fine. Otherwise, normally you would have to say, oh, this transaction is for so and so account. You don't have a transaction without a account. So you can have, so if it's a class which is outside, oh, that is how it would have been. But if you have it as an inner class, you don't have to declare a account. It's an inner class of account. When transaction already has an account. Okay, transaction always has a account. Fine. Okay. So we will be having this example later, and this is just to associate here where we might be using the inner class thing. Okay.
So what if you want to access X outside of B and inside of A?
X outside of
B.
this x, this it's anyway. Acha, you want it inside A, somewhere inside A. It's available. Why? Somewhere inside A, fine. Somewhere inside A, you will have to create. So somewhere inside A. So let's say there's a method M2, which is method of class A. Fine. So you want inside the class A, right? There is a method M2 of class A, which says B1 equals new B. Okay. So let me put a method. So I am describing a method which is here. Slow kar diya pura.
Wi-Fi थोड़ा slow दिखा रहा है।
One second, I think. Okay, so let me put the method which you want here. Fine. So assume this method. I'll be putting it somewhere down. Okay. So what could that method be doing? Okay. So you have your method M2, which is inside class A outside B. Fine. It's a member of class A. So its void method is M2. Yeah. Okay. So here you want to use the x of B. Now in order to have x of B, first you must have object of B created. So you will be having B1 equals new B. Fine. Now when you are writing new B, it actually means this dot new B. This is the object of A. Fine. Because it's inside the class A, I need not say A dot B, I may just use it as B. Fine. This is A dot B, but huh? No, A dot B. It's a type name. Name of the type is A dot B. The name of the variable used is B1. Fine. And now, which x do you want? You want this dot x? If I say this dot x, I have B1 dot x. Yeah. That's how it says. X is private, that's fine. You can use it because it's member of A. B is member of A. Private inside B is available in A. Fine, clear? Fine. So instance variables, part of object. When the object is created, object is of one of those classes, right? Each class has its own instance variable. It can decide whatever name it wants, and it can be the same name which appears in some other class. Fine. Okay, and this is member of class A. Okay, so we will have to find later. We'll have the example about having transaction as an inner class of account. Fine, we'll have transaction as an inner class of account. That will come later. Okay. Okay. Before that, we'll have to also look at another type of nesting which is allowed. Okay. Let's see the other type of nesting which is possible. Like variables can be static variable can be instance variable. We also can have variable which is a local variable. We can have local variables. Similarly, we can also have a local class. We can also have a local class. Let's see what is a local class. Where does it go? So you got class A. Okay. Now for our example here, I am taking a declaration. It has a variable, private variable. Maybe it's a static variable, but the type of the variable is account AC. And so there is some variable account AC inside the class A. The type is account. Okay, for some reason I have kept it. Let's see. Okay, now the class A has a method, right? So there might be a static method, non-static method. So there is a method returns void. Method is M1. Yeah. Okay. Parameter may or may not be there. But inside this method M1, we have few statements, right? We might have a few statements which execute, but then comes a local class. Local class means inside a block, which could be a method block, inside a static block. Fine. Not directly inside the class. Fine. We saw member class B as a member of class A, but not that place. Now we are saying, oh, we might have a class B here. Now, when I am defining a class, I can use whatever I have. So here what I want is, I will say, okay, we have class B which extends the account class. And this has its own definition where it might be overriding some method of account class. Okay, so that's my method, and you might have a few more things, and there would be your end of your class A, right? Yeah. So this is a local class. Local class, like the inner class, cannot have static members. Cannot have static members. Fine. Now another thing to look at here is, we have method M1 of A. Okay, this is static or it could be non-static method. The method here could be static or non-static. If this is a if it's a static method, M1 is static. Fine. If M1 is a static method, then inside this class definition, which is the class definition for B, we can see one more thing here, that method M1, fine, the method M1 will be used on, if it is static, it's not used without, it's used without any object, and therefore inside the method M1 what's available? I don't have any implicit objects. There's no this or anything. Okay, other thing to note here is, when someone calls method M1, What's the use of this one? Method means execute statements, right? Now what is this class definition? Is it some executable thing? No. It's going to execute this statement, and then straight away here, here and here. When someone calls method M1, this is what's going to happen. You just have to ignore from the execution point of view what statements are executed on this. That's a definition which is used by the compiler. When the compilation has taken place, a .class file was created for it. When the runtime loaded the class, yes, it loaded the class definition for A, it also loaded the class definition for the local class. That class definition was loaded. Fine, when someone calls method M1, yes, this class definition is not executable kind of thing. Oh, there's a declaration of a type, that's it. It's not an executable statement from that point of view. Fine. So let's put some place where we would like to use the class B. One thing, B is a type, fine, but this type is available like local variables. This type is available for use only inside the method M1. Okay, so let's say we would like to use it. How do we use it? So some place he says, okay, you have object, maybe it's an instance method, fine. So I have this dot AC, right? Account AC is available to me if it's an instance method, is equal to new B. The constructor here is now being called here. Fine, you may be using the things from there. Fine, call the constructor, create object of the class B. Fine. Okay, and fine, because it's a subclass of account, I can assign. So that's the reason I had one variable like this. Okay, now coming to the class B, what can I use inside the class B? Class B extends account, it has overridden some method of account, maybe the deposit has been overridden. Fine, let's assume some method here has been overridden. Okay, the question is like this now. I have a local variable of method M1, I have a local variable X here. X is a local variable of M1. Can I use X, that local variable X, inside my class B? पहले एक बार डिस्कस हुआ है कहीं पे सिमिलर थिंग. आई थिंक वी डिस्कस्ड इट विद लैम्बडा. Whether it can be used or not depends on whether X here is final or effectively final. Recollect that, right? If it is final or effectively final, then yes. Otherwise, no. Right? See, when M1 is called, X comes into existence. Why no? I am showing the reason why no. When M1 will be called, X comes into existence, and when M1 is over, X will be removed because it's in that part of the frame. That frame is gone. When M1 is invoked, the frame is created, or the local variables are part of the frame. Fine. The execution of M1 is over, the frame is getting removed. The next statement after whatever invocation of M1 was there. Okay, fine. So that's the reason why, see, the life of this, the life of the object of B. What's the life of the object of B? Is it over with the execution of M1? No. When M1 finishes, is the object going to be cleared? Is B not available from AC? It's available from AC. What is available from AC? The object of B. Right? Fine. See, later someone calling AC dot deposit. If someone calls AC dot deposit, what happens? Deposit was overridden on class B. Which deposit will be used? If I say AC dot deposit, which deposit is used? The deposit as defined in B, because AC has reference to B. Fine. So inside class B, if I was using in the deposit method, someone says, oh, let me use that X thing. If I was using X, right, then X is no longer there. See, the time when deposit is called, that's not necessarily X exists. X doesn't exist. The life of this is different from the life of M1. Class is just a definition of a type which you have defined. Fine, it's a type, it's not an executable statement. The usage of this type is happening even outside M1. The name is not available, that's the only thing. The name B is not available, the name of the type is not available outside M1. B as a name is available only inside M1. Fine. Nowhere else I will be able to use the name of the class B. I won't be able to call the constructor outside the method M1. But I can call the constructor and assign to something like this. And still available outside the method. Finds the reason why a local variable of the enclosing method, the local variable of an enclosing method cannot be used inside a local class unless it is final. If it is final, what is done? Whenever any object of final means it has just a constant value. Okay, so whenever an object of B would be created, that would be put inside the object. Okay, it's also put inside the object. It's copied specifically. Fine, a copy of that would be put inside the object. Okay, that's how the final variable usage has been allowed inside the final local variable of an enclosing method is usable inside the local class. Fine. So other thing was about the local class, two kinds of nesting. The third thing we have seen, which is related to nested, is the anonymous class. We have seen the syntax for anonymous class already. Fine. So nested things, yeah, three things to look at. Fine. Nesting is inside the class, so we have the top level nested class and the inner class, that concept. So it's a member of a class. Other nesting is in the local class, and third thing is the anonymous class. And we had seen anonymous earlier. And last time I think we saw about anonymous. Right? We have used it's just a syntax. Anonymous is a syntax. And new, whatever the type of object you want, use the constructor and give a definition there. Okay? Right. Next time I think tomorrow what we'll do is we'll look at the example. Fine. Now for that example we'll have to look at a few more things, a few more types. We'll have to look at the date and time thing. Date and time. In Java, how do we use them? What are the things available?